So hey folks, this is Miss Gray with Falcon High School Chemistry.
Dean Huffman with Vista Ridge High School Chemistry, and we're about to talk to you about significant figures.
Yep, so get ready to pause and rewind because this takes a little time to work through.
All right, measurements in science. From our last podcast showed you that you needed to be precise and hopefully accurate. You need precision and accuracy. And now we're going to show you how that relates to significant figures.
Right, every measurement you make is going to have some amount of error in it, and that's going to show up in our answer. It limits how much error is in your answer as well. So, depends on the type of instrument you're using and how much uncertainty you'll have.
And you'll be able to tell by its printout or by its specs or by the measuring device itself.
Right, look at your measuring device. If you have a ruler with millimeters, then millimeters is the limit to how accurate you can be. So you'll have in every measurement you give us some digits that are certain that you were able to actually read on the scale, and then another digit past that that's an estimation, where you're making a guess. Is it halfway between the 2 marks, or is it less than halfway in between 2 marks? It would be like measuring your height on the basketball team, right? You have how many feet and how many inches, and then...
And you can go to half an inch, especially if you're looking for that scholarship.
Exactly. So here's an example where I put a picture, go ahead, of the metal rod and the ruler that we're going to use to measure it. And this is in inches, just to give you practice.
Now notice you can read it out to the tenths right here. But it doesn't stop there. It goes a little bit past the halfway mark, so I'm guessing that this is 1.4, and then I'm going to guesstimate this last digit. Since it's half, I'm going to say it's 1.48. I'm not sure about that.
Because it's a little more than halfway.
Yeah. So your best estimate on that.
Yeah. So let's look at this measurement. There's markings for every tenth of an inch. So we can say that the rod is 1.48 inches. So the 1 and the 4 are numbers that we know for sure because we have marks for those. But the next one, the 8 in this measurement, in the 100th place, is our uncertainty digit. We want to have it there because we're making the most precise measurement we can.
Notice how much more accurate it is to guess this last space. Because if you said it was just 1.4, you would be 8/100ths off.
Right.
Now, even if we guessed this wrong by 100th or so, we'd still be much more accurate than 8/100ths off. Suppose it actually is a 7 or a 9, then we're only off a very little bit. So this gives us much more accuracy.
Yes. So in every measurement you make, look at the markings you have and then give us one more after that. So what we're looking for here is the numbers in your measurement that are meaningful. And it's going to depend entirely on what instrument you're using. So exact numbers, and what I mean by this are counting numbers.
Numbers like the number of students in your classroom.
Yeah. These
how many
have
straws you have.
Unlimited Sig Figs. Like if we had 11 soccer players, then you wouldn't have 11, it would always be 11.000000 and keep going forever.
Infinitely zero.
Because you wouldn't say 11.1 saying that you had 11 kids out there plus one arm from another kid. Right? That would be
That's
weird.
correct. That'd be kind of neat.
Yeah, instead of an extra arm, you could block the soccer ball. Okay, so which numbers count as significant numbers? Well, all of them, unless it's a 0. So all non-zero numbers are significant.
There's some rules on zeros you're going to see here in a second. Yeah. Some zeros are, some zeros aren't.
Yep, and that's the frustrating part. We've got a lot of rules to remember. So we'll try and make it simple for you. The first one is any 0 that's between other sig figs is automatically significant itself. .04,
the 0 would be significant because it's between 2 numbers.
Right. Okay, if we had a 0 before the first number, then it would not be significant. Want to show us one of those?
So if we had 0.0 0.058, the 0 is only holding a decimal place. It is not significant.
Right. So the 0 only tells us what place value that 58 has. Okay, then a a 0 that comes after the last number is only significant if it's after a decimal point. So it comes after both a number and a decimal point. So that just comes after a number, not significant.
But if we stick a decimal point in there, then it becomes significant.
Right. Oh, there it is. So if we write the decimal point in, or suppose that instead of having that there, I had this point here.
Then those zeros again become significant.
Right, because
Because
they
you
follow
can be
digit.
exactly 0, 0.
Yeah, they follow digit and a decimal point, so they're counting as significant. So let's practice real quick. This 3200 has 2 sig figs because these zeros follow a digit, but they do not follow a decimal place. So they are not significant. We don't count them as significant. How about in this one?
Now this time you can see that there's a decimal point here. So 1, 2, 3, 4. All 4 numbers are significant.
Right. So, there we go. Maybe. Right, there it is. That decimal place, that decimal point makes a difference. Let's do another one. What if I have the decimal in between?
Now they're getting a little bit sneakier, but it's the same rule. Since there's a decimal point here, you've got 1, 2, 3, 4 significant figures.
Right, and this 0 counts because it follows both digits and a decimal. This 0 counts because it is between 2 other sig figs. This is significant and these are significant.
And it's significant because it has a decimal there again.
Right,
There it
there's
is.
that decimal. So pay attention to the 0 rules. The zeros make our life a little bit tricky, but we're going to support you. You're going to get lots of practice. So let's try these. You follow along, and some of you are faster than we are. So you can write in your answers and we'll explain it.
All right, we've got 4 digits and we have a decimal point there. So it's holding them all accountable. So it's again 1, 2, 3, 4, 6.
Okay, I'll take this next one. We have this non-zero that I know definitely counts. The zeros will only count if they follow both a digit and a decimal place. And I don't have any numbers in front of this, so none of them count. I have only one sig fig here.
So it's holding the spot those zeros are. It's
Right.
just there so you can write it.
Yeah, so I know that it's 7/1000ths and not 7,000,
Now, we don't have a decimal here.
right?
It's missing. So these zeros are just holding a place for us so we can write 6,800. So this only has 2 significant figures.
Yep. You gonna do one more?
Yeah, I'll do another one. I'm on a roll. All right, now we got to take a look at this. And since it has a decimal, this 0 is going to count here. So this one again has 1, 2, 3 significant figures.
Good, well I wanted to do this one because it looks so easy. I don't have any zeros, so I automatically know every single one of those digits is significant. How you like that, Mr.
Yeah,
Huffman?
sneaky.
I took the easy one.
Now we got another one with the zeros, and since it's got a decimal point again here, and it's got a digit at the end, we know that they all count. So once again, we're at 4 significant figures, and it's 1, 2, 3, 4, and the decimal makes it all alive.
Right, and any 0 between other sig figs is automatically significant, so both of our zeros get to count. In the end, though, this could get tricky. My rule says any 0 that follows digits and a decimal place gets to be significant. So this one is a significant 0. Then I have zeros between other sig figs, so they all count. 1, 2, 3, 4, 5 sig figs in this number.
There we go.
Yeah, that's how
Wraps
you do
it up.
it. Okay. Now let's do some math with sig figs. Multiplication and division will be easier for you to handle because then we're limited in our answer to the number of sig figs in the
Yeah, all you have to do here is
percent.
multiply them using all the digits provided, or divide using all the digits provided, and then count your significant figures based on the number with the least amount of significant figures. So this works out pretty nice.
Okay, so get your handy calculator Thank you. And we're going to multiply these two numbers together. And I'm going to identify here, I don't have any zeros in either of these. So I have 3 sig figs in my first number and 2 sig figs in my next. So find the product of these two.
All right, it's 2.882.
2.882. And if you write down everything that your calculator tells you, this is called calculator vomit. This is not your answer. This is just what your calculator spits out. You're not allowed to give me an answer that looks like calculator vomit.
That's a nice term.
Yeah, isn't that beautiful? Look, this
Now
one's
you get to go to the east, well,
limited to 2 sig figs.
the smallest one is 2 significant figures. So we're going to take a line and draw it through there. And we have 2.882, and since 8 is greater than
Greater than 5.
to 5, we're going to round up to 2.9.
Right. Follow the rules of rounding after your significant digit.
Now remember the rules of rounding. 5 or greater, you round it up.
And if
Otherwise,
it's less
leave
than
it the
5,
same.
right, leave it the same. Okay, let's look at addition and subtraction.
This is the one that gets students.
Because now we're looking at decimal places, not sig figs. Decimal places. So let's use an example. Same numbers, but now we're going to add them together. So remember, when you add numbers together, you want to line up the decimal places, right? So they're not lined up very well on my slide, but
Now you see them.
yeah. So I can write in the 0 to add things together.
Remember that 0 was not a significant number.
Right, exactly. I put that in there so I can add things up, and you don't have to do that.
Absolutely not.
Great, so let's identify the sig figs here. We had no zeros, so they're all significant. And in this one I had the 2.2, 2 sig figs. Do I care?
Yeah, we care. We're only good to the tenths here because our weakest number, 2.2, is only good to the tenths.
Right, so
So
I don't
we're
care
going
about
to-
sig figs, I care about decimal
Right.
places.
We're only
Right.
worried about the tenths, so we're going to round that
So here's my 10th place.
to fifth.
Yeah. So 6.51, this 1 is not big enough to make a difference.
Nope, it's less than 5, so it's going to stay the same.
All right. Hey, I didn't add correctly the first time. I'm glad that I have the right answers here. See, everybody makes mistakes,
There we
right?
go.
Yeah, even me. So 3.5 is all that we get to keep. Okay, we get more practice. Now we're going to add 3 numbers together. And it's okay to use your calculator to do this, but let's talk about the rule for addition.
Right off the bat here, you know that the only one that's going to matter are the tenths because you only can go with the number with the least number of significant figures.
Oh, I don't care about sig figs.
Not significant here.
Decimal places.
Decimal places,
we're
with the least
adding-
number of
Right.
decimal places.
This
Because
is
all of
2.
them are significant.
This has 1 decimal place, and this has 3, and this has 2. So this is our limiting factor, right?
That's right.
Yeah, so we don't care about sig figs when we're adding
No.
or subtracting. Yeah.
That's
But
correct.
let's go ahead and do the math. You want me to run the calculator and you can write? I'll trade you.
Okay.
Great. Here we go. So 2.36 plus 1.7
Yeah, we'll move that up.
and 3.284. So my calculator vomit is 7.344. And we get to keep only 1 decimal place. So look after the 3 and see, is that 4 going to make a difference?
Doesn't look like it. It's
Good.
not higher than 5, so our answer is just going to be 7.3.
Right, and you put a box around your answer because that's the way. I love it. Okay, let's do multiplication. What's our rule for multiplication?
Now, this one is significant figures, not just
Right.
decimal
We're
places.
paying attention to all the sig figs, so
And we only
we're gonna
have
multiply.
3, so our answer when we're done getting the calculator vomit, we'll only have 3 significant figures.
Okay, here's my calculator vomit. You ready? I multiplied them all together. I get 12.5728,659.
And we're looking at 3 significant figures,
So we
so
have
this is
3
going to
digits.
be 12.6. We counted the digits over, we rounded on the last one, 7 was greater than 5,
Mhm.
so we kicked it up.
So what you're saying is, none of these digits are meaningful,
No, not at all.
so we don't keep them.
And if we added them in, we'd be adding dangerous error into the experiment.
Right, exactly. Okay, let's divide. What's the rule for division? Are we
Same
counting
as
decimal?
multiplication, and we're looking at significant figures,
Right.
not decimal places.
Sig Figs for multiplication and division. So my calculator vomit for 8.2 divided by 3.74 is 2.19251339.
369?
Uh-huh.
All right, we have two significant figures.
Right, we're limited
counted
by that
over.
8.2 number.
9 is definitely greater than 5, so our answer is going to be 2.2.
Good. Put a box around your answer, because that's the way I like it. Hey, look, we have 4 more example problems, and I'm going to let my students solve these.
Yep,
And we'll check them when you come to class. Make sure that you work through the rules that we showed you.
and remember the rules are very easy. Multiplication and division, you're looking for significant figures. Adding and subtraction, you're looking for decimal places.
Right, that's it, guys. Good luck. See you tomorrow.